Gadgets Live.
Hello, welcome to Brown Dog Gadgets Live. I'm Amanda, the Education Outreach Coordinator here at Brown Dog Gadgets. Behind the camera, I've got Pete.
Hey!
Today we are going to be jumping into another episode of MicroBit University. But before that, if you have not followed us on our social media platforms, please do so. You can find us on Facebook, Instagram, Twitter, or X, and YouTube. Also, the project that you see today, as well as all of our other projects, templates, and products can be found at browndoggadgets.com. While we're streaming, if you have any questions or would like to just chat with us, feel free to drop something in the comments. If you have any questions after, you can email us at help@browndoggadgets.com.
Yeah.
Awesome. Today we are doing MicroBit University with our Piezo speaker, which we've done for a few sessions now. But this time we have 4 push buttons. Let's switch to that overhead cam.
Okay.
All right, so we have our Piezo speaker hooked up. You can see that the black hole is going up to pin 8. The white hole is negative. The ground side is leading all the way to ground over here. And then Pete connected 4 push buttons separately, all connecting to ground, and then to pins 1, 2, 3, and 4.
And you could obviously put those buttons right next to each other.
Pete likes a little space
less
for his
tape.
fingers.
I like people to have to work out the traces, and I don't know, that's just me.
I like
You
it.
gotta work for it. I don't know.
Yeah. All right. So the very first one that we're going to do is Piezo Piano. So when we put our MicroBit in, when I press the button and hold it, it plays a tone. Fabulous.
There's another trick too. If you press a button on the left, all the way on the left, hold it down, and now press another button and release it so you can get sort of working. It only works in that direction though.
I was going to say, it didn't work this way.
Right. And we'll see that in the code. Should we look at the code?
Let's check it out.
Let's look over it. Oh, I'm there twice. Cool.
Double P.
All right. That's what you need, right?
Yep.
Okay, we're up to 15. Look at this.
I mean, it would help getting the MicroBit University chapters done if we had double P.
Oh, maybe.
Maybe?
Or it would take twice as long.
No.
With the other one. Okay, so this is that one. Right?
Mm-hmm.
Let's take a look. We went through all that. Let's look at this code here. Okay, so this is pretty simple. Looks pretty simple. So you'll notice that, and we saw most of this, I think, with the previous lesson or the previous chapter. We're using audio pin 8 because we have our Piezo connected. It's also playing through the built-in speaker. Why not?
You can prove it by taking off the speaker.
Yeah, it'll still work.
It still works.
And to save us, I set the volume at about halfway. I didn't go all the way up because...
Thank goodness.
We set our pull pins. Those are where we're going to have those buttons attached. Now over here, you'll see we actually reversed the order. So we're doing 4, then 3, then 2, then 1. And that's because, as you saw, when you press like that left button on 1, it's going to do that. But if you want to press, any of those buttons to the right of it and have a sound, you can do that. So if you reverse this and have 1, 2, 3, 4, you do it the other way. You'd have to press a right button and then a left button to get it to do that. So
Gotcha.
one of the limitations of sort of this style of if-else, it's gonna, if they're all true, it's gonna go for that last else statement, else if statement. So pin 1 is gonna win.
Could you do them all in their own if-else?
You could, yes. Oh, hold on. Wait. Piezo. Yeah.
Worked so well there, Mike.
Come on, Mike. Put some effort into it at least. Yes, you could, and I'm glad you asked. We didn't even plan this. I hope I'm saying this right. Amanda, do you know what polyphony is?
Nope.
So there's monophonic and polyphonic.
Sure.
And polyphonic is the ability for a device, instrument, to create more than one sound at once. So if you think of your classic like mechanical piano with strings, you can hit 2 keys, and they'll play 2 sounds at the same time. With a lot of sort of digital synthesizers, They are monophonic. So you can only kind of play one sound at a time. If you try to play two, you can do like chords, but it can't really play two distinct things because there's limitation of like certain synthesizers. And that's kind of how the MicroBit is. So it can play like one sound at a time. So that's where you were playing one sound, and when you press that button, it played the other sound instead. So if you release it, kind of, yeah. I tried a bunch of really weird code to like demonstrate this in more depth, but then I realized like it doesn't really help. I think this is demo enough to kind of show you, and that's this is kind of how microcontrollers work. They're pretty much monophonic. You're going to get one sound of it at a time. Now, could you play different sounds on different speakers? Possibly. Possibly. You need a way to sort of route it to each speaker. So I haven't done that with a MicroBit, but I think that is doable with certain other systems. But we won't get into that. Again, MicroBit makes this stuff pretty easy. We're not going super in depth. We're trying to get you just familiar with all the basics.
Right. So would you then turn on or turn off the speakers in the specific forever loops?
Ooh, so again,
instead of on start?
This does a stop all sounds, but and do we need that one there? Yeah, we need that one there because in this case, we're just checking if a button is pressed. But we could add, each could have like an if it's 0, play this, but if it's 1, meaning the button is not pressed, do something else, which would be not play a sound kind of thing. Like I said, if you try to get super complex with sound, it's tricky because there's only one speaker. You can kind of only do one sound at a time. So, but you can still do some fun stuff with it. Yeah.
Awesome.
All right.
So then, I don't really need to change the MicroBit, but I'm going to anyway.
You don't?
Well,
you should.
I'm going to.
No, I get you.
So B is piezo piano case.
I don't know how I come up with these names. It seems like it's the same thing.
It's the same thing.
It is the same. You'll get the same end result.
Right.
We do a slightly different thing over here. And this starts all the same.
It is not all the same.
Is it not all the same?
Nope.
Oh, we added
tone case.
Yes. So there's another thing which is called, can I fit all this on here? Yeah, good enough. So besides this whole if-else kind of ladder, as it were, there's something in programming called switch case, in which you sort of, you get a value, and then you can have it go into this switch thing where it looks at what that case value is, and then it just executes the right one. So instead of this else if, I can't even say it. It's sort of a more efficient way to do it. It doesn't look like that exists in the MicroBit world, which I get because it's a little weird and complex. Like when I first saw it years ago, I was like, how does this work? And it's a little more tricky to read it and understand, I think, than the if-else. If-else is pretty darn simple, right? You've got if, you got else, or you got an else-if, and a bunch of them. So simple to explain and understand. But what we're doing here is instead of playing the tone right here, we're actually just setting that variable to a different number, either 4, 3, 2, 1, or 0. So 0 if none of these are true. And then over here, we're checking, in another forever loop, we're checking what the value is and then doing something based on that.
Got it.
And this is, again, this is a way, what's Mike have to say? Right, Mike, of course. I didn't even mention that. But in the switch case, is it just going to, that's to get out of that case? Or the switch statement, I can't remember. It's been a while since I've used them because I'm doing stuff like this. Mike will probably tell us. But yeah, so 2 forever loops, so they're running at the same time, running concurrently. And you could do more inside of here. And we'll see in the next examples too that like at some point, this forever loop can get a little scary with how much code you can put in there, especially since you got kind of limited real estate here, and trying to see all that code can sometimes be a little tricky. So we're going to get into that in the next example.
Awesome. Then we've got C, which is piezo siren. Now this one is pretty fun.
You can see what's coming up.
Are you ready?
Yeah, I'm ready.
Fancy. Pete, which one's your favorite?
Headache inducing. Ooh. Play that first one again. Play the last one. I think the last one.
Mm-hmm.
Yeah. Okay, so our code here, and seriously, look at this. I mean,
that's a lot.
It's a lot, but it also gets difficult to kind of keep track of it. So like when I was making the screenshot for this, I kept like grabbing the wrong pieces because I do it in multiple parts.
Mm-hmm.
But anyway, what we've really got is there's one block, there's 2 blocks, there's 3 blocks, there's 4 like different blocks basically. And what we're doing in that block is we're checking again to see if we're pressing that button.
Right.
Then we set the pitch value here. I just like to set them on start of a program just to remember that they exist. But over here we're setting it to a new value, 200. Now we're doing a loop. So I know I had mentioned this before that like I was kind of bummed that like this for loop always starts at 0.
Mm-hmm.
And it does, but because in other programming languages you can start it at anything, even negative numbers or whatever. But your start is always 0. You can put in any value you want. Let's see what Mike has to say. What does he have? What does he say? Mountain
bike mountable megaphones.
Mike, I want one of those. I don't know what that is, but
you'll have to earn enough points.
I actually have I
Fundraising.
have a bullhorn and a bike, and I'm working on a way to mount it. But that's for another day. We'll get into that later. Anyway, where was I? Okay, so this for loop, it always starts at 0. But the thing is, you've got addition, so you can add things. So over here we're saying set pitch value to pitch value, which is going to be 200. Plus index. So we're really starting at 200 and 0. So 200.
So I didn't actually look at the code before this.
Okay.
And I really just thought that this was like a set of like a certain melody.
No.
It is not.
This is mine. No, it's a siren.
Yeah. All right.
So what we're doing here is we're setting that pitch value to 200 plus 0 on the first time around, and then we're playing that value, and then we pause just 1 millisecond, loop around. Next time it's 201, 202, 203, all the way up to 230. When it reaches that, it exits that loop, and remember we're still at 230, right? So here it's 230, and we're going to go from 0 to 30, but we're going to subtract.
Okay.
So now we go 230, 229, 228, all the way down to, 30 times until it gets back to 200. So from here it goes from 200 to 230, and then from 230 to 200. So that's what happens in this whole loop.
Yeah.
All right, so that's how you get that woo, woo. So it's going up, it's going down, and it continues to do that as long as you hold the button. And from there, it's just each block is the same, except we're doing a different value, or maybe pausing a different amount. We kept the 30 the same, I think. We could have changed that too, but so yeah, it's basically
But it's all about how long you're holding it down, isn't it? Oh no, that's the like section of
for how long you play. Yeah, it's going to do that as long as you're holding it down.
Right.
And basically, we got 4 different blocks that are pretty much the same, except for those numbers that we put in there, right? But again, this is a little unwieldy, especially in make code, where it's this block thing and you can't really add sort of funky formatting or whatever, or like comments to like break things up. So that's where we're going to fix it in the next one.
All right.
Yeah.
And the next one on the visual and sound end of it is exactly the same.
I think it's exactly the same, right? And look how compact
I mean, I'll swap it out so you can
Yeah,
see.
you should swap it, just so we can prove we're not lying here.
There we go.
So, same functionality, right?
But using a
code.
function.
Yes. So, this time, we've got our button presses, just like in that second example, sort of, just do these button presses and do a thing. This time we're calling our function, and we have 3 parameters that we pass to it. So if we look over here in our function, we have our pitch, our steps, and our delay. So then instead of, like before you saw a bunch of numbers typed in here, you're going to see we've got our pitch right there. Instead of typing again, we're pulling it from there. Our steps, we're getting that from there. And our delay, we're getting that from there. And we're reusing those all down here. It does, sometimes it will create this is index 2, because I have 2 indexes in this loop. So occasionally if you duplicate some block of code in MakeCode, it'll call it index 2, index 3, index 4, whatever. It'll just add a number to it if there's some weird conflict. And yeah, so you can see that here too. So just because variables are weird. There's global variables which exist throughout the program, and then there's local variables which exist within sort of a function or a specific loop or something. But MakeCode pretty much takes care of that. It's not gonna, let you do something wrong. It's basically gonna take care of it for you. But yeah, you can see sort of how nice functions can be, because this is my whole program really. If I want to know what this play sound is thing, I just look over here, but I can see all the logic of this program, right on the screen. I don't have to scroll and try to remember which block is which. So functions, super handy. And again, functions, if you remember, over here you make a function and you can, do something. You can pass in numbers, multiple numbers, and pass in some other things too, like an image. I haven't used that one. Text, some other stuff, booleans and arrays, That should be a pretty crazy function. Yeah, we haven't really touched on a lot of that stuff. We don't really use text a lot because it's mainly used for scrolling across the screen, I think. And we don't do a lot of that because it's hard to read.
Yep.
Image, I think that's just the image thing. No, sorry, that is the image thing from here. So you can create a thing on the matrix or a scrolling thing. Again, we don't do a ton of that because it doesn't fit as much with what we usually do.
Yeah.
But functions, super cool, super useful. That's what we got.
Awesome.
Yeah.
So that is the Piezo speaker with 4 push buttons. It's pretty fancy.
It is.
Now, before we're done today, and I don't know if you actually knew that we were doing this today, Pete.
I have no idea what's about to happen.
Josh has been working on something, and I've been helping him.
Oh, Josh he told me that if we need his help with anything, let him know. And that's all he said.
Okay.
I didn't know why. I don't know why you told me that.
With our MicroBit, we connect it to our Bitboard and the Bitboard rover. The rover has a grabber, or a gripper. It's called a gripper.
Right.
Yep. Nice basic build. It works really well. It's great. So you can grab something, move the rover around, release it. Josh has been working for a while on figuring out how to grab and lift.
Years at this point, I think. Or over a year for sure.
Yes.
Yeah.
So in the last workshop that we did, he talked about it again and then got reinvigorated on figuring out how to make it work.
He did.
So we are very close to actually sending this out in our rover kits as an additional build. We're calling it the Claw as of right now.
Okay.
As of right now, it's called the Claw.
Okay.
So we're going to show it to you.
Are we?
Yes. He wanted to show it off.
I didn't know any of this.
I know. So it is still, it's not out yet.
Okay.
I've been working a lot today and yesterday on figuring out, what color pieces look the best and how to make it. We've been finessing it. So
Okay.
here it is. It's hard to see on the black screen, but it is an add-on to the rover, and you do have to modify the rover a little bit. So we bring the bit board up and we put a 270 servo at the back, and then it goes through here, comes to some gears, and it's got this attachment on the front. Now,
Are you going to demo it?
I am going to demo it. I'm just wondering if it's easier to see on the white.
It might be, yeah.
Yeah,
There's
I have a
no
white
black
piece of
in it.
paper
Here,
right
get
there.
that. I can get a larger piece too. Yeah.
I mean, I could. That's so much easier
Oh,
to
that
see.
works, yeah.
Yeah, so the way this works, and if you already have some rovers, we are planning on doing this where you could just buy a bag of the extra parts.
Add-on kit.
An add-on kit.
Yeah.
But overall, it will come as an extra bag in the rover kits going forward, which is pretty awesome. So we got our controller. I gotta slow it down because I don't have that much space here. Wow, too slow. Okay. So we have our rover. It's got the mind of its own today. But if I press the buttons, it squeezes and lifts and then releases. So
Yeah. This is a super cool
it
mechanism.
really is.
Like I told Josh, it's still a little bit magic to me.
Yeah.
I get how it works, but the first time I saw it, I was like, wait, that's impossible. What do you... Wow,
It's pretty cool.
It's magic.
So it takes some like skill to actually pick things up. It really does.
It's advanced for sure. Yeah,
But-
got it.
You can lift something,
Yeah.
move it around, take it somewhere else, drop it down.
Yeah. Because
We've even played around with grabbing a ping pong ball, lifting it up, and dropping it in the cup.
Right.
And we've done it.
Because our gripper right now is basically 2 fingers, and you can corral things and
Right.
move them. Push
Corral
them
is a
along.
good word. You can
Yeah,
corral something.
Yeah, and move it around on a surface. But this one, can actually pick up an object, pick it up, and then you can move with it.
Let's see. I have not tried to put it in a cup.
Oh, yeah, yes, Mike. You hook it up to whatever crazy thing you build during Pathfinder.
That's right.
So, I don't know.
All right.
Oh yeah. Oh.
I got it. I just made it fly away.
Yeah.
Yeah.
Yeah,
So
this is we did the code for this yesterday, I think, and you kind of finished the build pretty much today. But
Yep. Yeah.
this is great.
So it is pretty cool. We're pretty excited about it. We've got to test it out, make sure that things work consistently because it's doing something funky right now.
Yeah.
But it is in the works, and we're really excited about it.
Yeah, and then I know we're also gonna update a lot of our guides just to make sure things are clear and simple, easy to follow.
Yep.
With a couple updated or outdated photos, illustrations, make things just more clear. So more guides coming. I know we talked to you about like some gamification style guides.
Yeah.
But yeah, people seem to enjoy it. We did a bunch of programming last week and last month on the rover, and people like it. So we're just gonna keep doing our best to make some great stuff for it.
Yep, absolutely. So coming soon.
Oh, Mike's got the explanation. He, of course, he's like, oh, I know how this works.
Right.
Dummy. Pete, you big dummy, come on.
Yeah, so when it actually hits here, it then switches and just goes up the axle. I don't know. Mike would have explained it better.
Yeah, well,
so
like
Josh
when
and Pete,
when
it's all good.
the smaller gears can't move anymore, then they move along the larger gear. That's, I believe, how it works. Right?
Sometimes it likes to push things all the way.
Easy to pull those off,
Yep.
reorient them, and put on some different ones too, I believe, right?
Yeah, we are going to have
Yeah.
a couple different options that you could put
Yeah,
on
there
there.
you go. Mike's got it now. You got it, Mike. That's
Yep,
the
so
magic.
once they hit together, these can't rotate anymore because they hit an object,
Right.
and then the axle then swivels.
Yeah. Now, Mike and everyone else, I first tried to design, so our gripper, the thing that's just, like that, I first tried to design one like 1985 maybe, and I didn't know what I was doing, so I was sawing wood and gluing things together and using a solenoid on like 12 volts. Didn't work at all. Like, but you know, I tried like almost 40 years ago. Anyway, so this is great. This actually works.
Yeah, it's pretty
our
cool.
gripper works. It's very cool.
Yeah. So Josh said, show it off today. So here we are,
cool.
showing it off.
I can show one more funny thing while we're waiting.
Sure. What are we waiting for?
I gotta get it.
I mean, I'm done.
Hold on.
But
Okay, hold
Yeah.
on. Okay.
you can show off whatever you'd like.
I'm going to.
Okay.
Just give me a minute here. So this is even like a precursor to all of that. Where is this? So
Double P.
I double again. So long ago, before we even had the gripper, Josh had this idea where he's like, oh, you know, the easiest way to do this is just kind of design the parts we need. Like, so this is 3D printed parts that are Technic parts, and you could build, you needed a few more parts, but this was like our very first gripper I think we had. So it was a 3D printed version, and it kind of worked. But this is kind of just shows the
Evolution.
the evolution
Yeah.
of like, you know, oh, here's the parts, you need a servo, and you can
Yeah, these 3D printed
this
pieces.
I think I probably printed these at home too, even maybe, but like, you know, this, you can kind of see where the servo, the gripper came from. Like,
Yeah.
You know, so that was fun. And this was, I don't even know, I think we did this probably earlier than that, in probably 2020, 2021, but well before we had the gripper or the rover. It was like, let's make a gripper. I think I even put this on an arm at one point and tried to pick things up. We probably have a video of that somewhere.
Nice.
I don't know.
Yeah. So, coming soon.
Yeah.
The Claw.
Cool.
Unless you have a better name for it.
No, the claw works for me.
I like the claw.
That's good. The claw.
Josh wanted the grabber.
The
I was like, I can't differentiate between the gripper and the grabber. That's not going to work for me.
Yeah, it's a little. I
Yep.
mean, the clamps maybe now. And then next week, maybe I'll have a surprise next week. I'm working on some too.
Oh.
We'll see.
That's true. Maybe.
Maybe if I remember to bring some parts in.
Yeah.
That's all good.
I mean, are you going to actually make a guide on that surprise or not? Because if you do, we could just do it as a live.
Oh, yeah, that's true.
Give you a little more time. We got a lot scheduled, so.
We can give I mean, maybe when you guys are gone, we'll just do another
There you go.
Pete show for an hour or something.
Pete show?
Yeah, I wonder. I'm trying to look. We did have, I swear, we made a robot arm at one point that used that gripper. I don't think there's any guide for it, but it might be a video somewhere. I'll dig it up.
Yeah.
Anyway.
I mean, I sprung this on you, so you didn't know it was coming.
It's fine.
Yeah. Awesome.
That's fine.
That is all I've got for you today.
Right.
Tomorrow is Friday, so we're not live streaming. I almost got myself thrown off.
Right, next week.
Next week, we have the CubeBot and the T-Rex.
T-Rex.
Yep, layered paper circuit.
Yeah.
And then another MicroBit University on Thursday.
Next. Yes.
Right?
Yes. Potentiometer and piezo, I believe.
Hey. All right. So
Something
we're
like
combining some things. Love it. So hopefully you'll join us next week. Once again, if you have not followed us on our social media platforms, please do so. You can find us on Facebook, Instagram, Twitter, or X, and YouTube. The guides for all the projects that you see, minus the grabber, doesn't exist yet, but can be found at browndoggadgets.com.
We'll work on it.
This was a sneak peek.
Right.
Sneak peek.
Yeah, sneak peek.
Yep.
Demo.
And then if you have any questions, feel free to email us at help@browndoggadgets.com.
Got it.
Have a great weekend, and we will see you next week.
All right.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. We'll see you next time.